Oh, and today we're going to look at this homework assignment on finding volumes, and the back is about velocities. So this first problem is an open top box. It's a classic algebra problem in which the length is reduced by two flaps which form the height of the box's volume. And the width is also going to have two flaps fold in. These two items will fold in and it will make a box, and the bottom will be the base area, but the top will be, this part will be the height. So to find the volume is length times width times height. The volume would now be 32 minus 2x. You take this amount, you always fold in two flaps. The width would be this way. So you're going to have 14 and fold in two flaps of 14 minus 2x, and the height is x. The next question asks you to find the roots. The roots of this, if you set it equal to 0, would be 16. The roots of this, if you set it equal to 0, would be 7. The roots of this would be 0. But you look at the next question, and it says, what's an appropriate domain? And I said 0 to 7. So to do that, we really need to graph it. So I have a graph of it right here. To get this nice graph, because if you start, it doesn't look like this, you're going to need to put in the domain you found. So 0 to 16. By the way, 16 is not going to count, but that's the information I have this time. And then later, you might have to look down here at the chart to maybe figure out some numbers that make sense. So sometimes you maybe have to skip a little bit to here. And you can see that here I have, like, the largest number I see is 625 or 4. So I'm going to put maybe 0 to, according to that chart, 650 would probably work. And then I get a pretty good graph. But then if I zoom out, I get a nice graph. Now the problem is we go, you can see from here that we have 0 and 7, and we do have 16 on this picture. And if this was a chapter 4 polynomial question, these would all be valid, but this is volume. So the volume increases until the maximum and then decreases back to 0, and then it becomes negative. What's happening here is that this fold right here is eventually too big to actually, it would go this way because the 14 is here. If I were to fold this in to the middle, it actually is also being cut. So I would actually cut this paper in half going this way. That would be bad. If I cut the paper in half, I don't have a box anymore. So in the real world, all these negative values, they're meaningless. The box was destroyed as soon as you cut it 7 inches, because what's half of 14? It's 7. If you cut it in half, it's destroyed. So that's why I said 0 to 7. I used an uninclusive notation. Instead of using square brackets, I used parentheses, because there is no volume at 0 and 7. I mean, that's what that's saying, right? The output 0. So I chose to use parentheses. If you put 0 to 7, I'm fine with it either way, because I mean, I'm just glad you understood it. But I think that they should be parentheses. All right, to put it in standard form, you're going to simply take that and multiply it out, just like in chapter 4 with polynomials. I started by distributing this x. That's why I have 14x minus 2x squared. You're going to fill in that box. Those boxes, you're going to get this. One of the things I'll show you that's cool is if you were to put that in there, so if you put that equation into that, what happens is you can actually check your work. So here's the original problem. If I put my foiled out version in here, notice that the blue line will perfectly cover the red line. And that means you didn't make any mistakes. If I did, let's say this was 446, look, oh, it's not enough to change. Let's say, look how much different it is. Instead of being 448, I put 44. It's not the same graph, but when I put the 8 in, boom, it's the same. All right, so we already made the chart, but let me show you how I did it. To make the chart, what you're going to do is you could put it in one at a time like this. B of 0, hit enter, B of 1. Notice that it doesn't like that you have two B's, so we're going to get rid of the original one, and then it'll tell you the answers just you see in the chart. But I kindly had a student show me something that was awesome recently, and that is that if you go to the gear, not the wrench, but the gear, you can choose a table, and you can just update it. I'm going to hit tab because I have a keyboard. You would probably on a tablet want to put it in there like that. It takes a little longer than hitting tab. But if you do have a keyboard, just go ahead and tab through the values, and it will spit out those output values for you, and it will even look just like it does on the paper. So thank you very much for showing me that. It was very helpful. So the next thing is, why do the values in the table go down after the height of 3? One reason is it's the maximum is between 3 and 4. But your analysis should include a description of the function in the real world. Let me explain what I mean. You all know from geometry that volume is length times width times height, but it's really area, right? Because length times width, it's really area times height. So what happens is as I decrease these flaps, the area of the base is getting smaller, right? So the area that I can actually put something into is getting smaller. The volume still goes up, as you can see in the graph. The volume is going up until I reach this sweet spot, which is the next question, called the maximum. So the reason that increasing the height decreases the volume eventually is the area in the middle is so small, it's like this big, and we have a very tall box now. The height's real big, the volume's small, because the volume is actually dependent upon the base area. Just an important thing to understand, that volume is really area times height. All right, so what is the maximum volume? We just saw it a second ago. All you're going to have to do this is just click right here. That's the answer. And then just keep in mind that this is only the height. So if I want the dimensions, how do you find those? Another thing that comes up is, Mr. King, why am I not using minus b over 2a and f of minus b over 2a? The minus b over 2a thing is for quadratics, and this is a cubic. So when you have a cubic function, the only way to find this value is through calculus. And you'll learn that in a couple of years. The algebra, this is just algebra, is the same. So everybody will use some kind of calculator to find this. We use Desmos right now, so we just click on it. If you had a TI, there is a maximum function you can use. Or if you had a Casio, same thing. You could find that by using the maximum function in the graph window. All right, so if I come up here, back to what I was saying, this 3.036 is only the x, the height. So if I need to find the dimensions, I need to find the length and the width, and I get them by just plugging it back in here. So, 32 minus 2 times 3.036, that would be the length, and the width would be 14 minus 2 times 3.036. And again, I got that 0 points right there, right? So I just put that in, and that and 3.036 are my dimensions, which is very important for the last question, right? So the last question says, hey, a toy manufacturer wants you to make a box that has 600 inches cubed to put in a new toy. What dimensions do you need to tell them the box would be if their shelves are 7 inches? So imagine you had 1,000 toy stores and they have 10,000 shelves and they're all 7 inches wide. You don't want to make a box that's going to stick out. So the way you do this is you put 600 in. Notice it doesn't show up. So you have to say that v of x is equal to this. And what that's basically saying is the same thing as this. Remember, this is v of x, right? And this is also v of x. So when they're equal to each other, that will give you the answer for the x. Very easy to do on Desmos. All you do is literally click. You might want to zoom in so you get a better picture. And keep in mind that this one doesn't matter, right? Because it's past the value of 7. So it's only these two that matter, this one and this one. So you can see I wrote them down, 2.392 and 3.711. But it doesn't want this, it wants the width. So you're going to go back and you're going to put it in the width. The width, you go back to the top, was 14 minus 2x. Okay, and then you're going to put in the value, so 2.392, and that's 9 inches. Think about it. That's the width. They're telling me that their widths are 7. This thing's going to be sticking out of the shelf. People are going to run into it. They're going to knock things on the floor. They're not going to want that box. So then you have to do the other one, 14 minus 2 times 3.711. Oh, look, that one's going to fit on the shelf, but they want the dimensions. So the last thing you do is you say the box is 3.711 by 6.578, and then you go back and also do the length, which was 32 minus 2, and then you put the value in there. Just pay attention to what you're actually being asked. So the dimensions are 3.711 by 6.578 by 24.578 inches. Don't forget here, when you did the volume, you had to report that as a cube. Now, this problem here is almost identical to the one we did in the notes. So just go back to the notes or search my YouTube page for a volume polynomial problem about a pizza box. It's the same problem with different numbers. It's already done. If you want help on that one, please look at that one. On the back, we have a velocity question. The first thing you're going to do is you are going to type it in. If you want to clear this out, again, same student, thank you for the help. You can hit the gear and hit delete all, or you can do it up here by going to the web browser and it'll clear it out too. So it'll just take me a moment to type this in. please be careful as you're typing to not make a typo. I had several students in class that they were frustrated because they didn't know what was going on because they simply didn't proofread what they typed. They just typed it in and then bam, that's what they had. It really is important to go back and double check. I even make typos sometimes, right? I just did, I'll go fix it. So like right now I see nothing. I forgot to hit shift right there, so I didn't get a, right? I'm just gonna make this bigger so I can look at it. I mean, it's looking pretty good. Let's see here. Just, it's super important to be able to look at this thing you typed and make sure that it is the right thing from the paper. Because if you type this in wrong, everything you do after this moment is wrong. Okay, the next thing it asks, now that we have it on there, this one was nice. You didn't have to change much. The way you would change it is you would use the domain 0 to 10. Notice this one is 0 to 10. Over here, when you do this one, you're going to want to put in 0 to 20 and actually locate it using 3,650 as the range value, because, well, that'll be explained in this part of the question. The first thing is, what is the v-intercept? The v-intercept is -23, which I can actually see on my graph right there. And that is the initial velocity. So when you do this one, you're going to want to change your range. When you do this one, you're going to want to change your range to 3,650 because that's my initial value on this other problem. All right, so for this one, the intercepts, you can see them right here, right? Feel free to move this around and maybe zoom in if you want to. Nothing wrong with that, right? And so my intercepts are 2, 6, and 8. And so what I'm going to do to make the graph is I'm going to put those 2, 6, and 8 on there. I put -23 on here. Notice that when I went this way, I went by 5s, but this way I went by 1s because, you know, this intercept is -23, so I need to get it in there. So I went by 5s. I actually skipped one and went by 5s, and here I skipped one and went by 1, so I had a little bit more range. And to figure out the rest of it, you sort of need to do the problem and come back. Please don't forget the graph that will be created. So the next question is, will this function factor? Well, if your roots are integers, will it factor? Think about chapter 4, right? If all these roots are integers, that means that their factors would actually be x minus 2, x minus 8, x minus 6 with some GCF, which is 0.24, by the way. So this will factor. The reason it wouldn't factor is if these were irrational numbers. It still would factor if this was 0.5 or something, because 0.5 is a fraction. Remember the rational root theorem? As long as these are rational roots, meaning a fraction that has an ending as opposed to an irrational number, this will factor. All right, then you make a chart. We already learned how to do that. Thanks again for the help with that. You just go to the gear and you select chart, okay? And hey, you can do 2 charts if you need to. And then you just put in the numbers 0, 3, 7, and 10. That's what they requested here. And I made typos, so let me fix it. So 0, don't forget to tab. I accidentally hit shift. That's why I made that mistake. All right, and if you want to get rid of one, you can hit delete. All right, so that's what I have in my chart. So now I put 15.36 where the 10 was. I'm just kind of adding the pieces in as I go. The speed is to take the absolute value of the velocity. So these 2 negatives become positive. Okay. When does the particle have positive or negative velocity? Well, the particle, I'm going to go ahead and draw the graph here. If I look at the graph, the particle is positive up here. This is where it has positive velocity values. So if this is, right, that's positive v of t, and this is negative v of t. So what that means is that this little hump here is positive, so from 2 to 6, and it's also positive from 7 to 10, and it's negative from, not from -25 on the x-axis, from 0 to 2, and from 6 to 7. So that's what you see me say there. I did include endpoint square brackets because it does end there. So the next question is the same, right? You might say, didn't you say previously that negatives don't make sense? They don't for volume, but for velocity they do. Because a negative velocity simply means I'm moving to the left. Glad I caught that because I had a little typo. So if you are moving to the left, you're negative. And if you are positive, you are moving to the right. Okay, so keep that in mind. If it was an up or down problem, positive would be right, negative would be down. So when is the particle's velocity 3? Well, you're going to set it equal to 3, just like we did before in the other one. So you're going to say, hey, where is v of t equal to 3? And then you just click here, here, and in this case, they all are correct. So you would write them all down. Unlike the problem with volume, where the problem ended when it was 0, all of these are correct for velocity. The minimums and maximums, you're just going to click here, right? And that's how I did those. These minimum and maximums, I wrote those down. So notice the 3.56 and 4.056 and the 7.097 and negative 1.2. That's how I graphed these black dots. But what are these other endpoint maximums? This is an important conversation about end behavior. So let's talk about that for a second. I'm just going to get a blank thing here. If you have up end behavior, these are both relative maximums. Okay. If you have down end behavior, these are both relative minimums. If you have a mix like this, right, this is a relative max and this is a relative min. And then we come to the problem we're looking at now, which is down and then up. So as you can see on the graph, I have a down up end behavior. So this is a relative min in our problem that is 0 and negative 23. And then I also have a relative max. And so now you can see why I included those in our answer, right? So the 0, negative 23, sorry, the 0, negative 23 is the minimum, as you saw right here, relative min. And the other one, that one is relative max. So that's why they're included. So what about the absolute maximum and minimum velocity? Well, velocity would be to take the absolute value of, sorry, that's speed. So what is the absolute maximum? Just pick the bigger one. And then minimum velocity, just pick the smaller one. For the speed, you take the absolute value of all of the outputs and tell me which one's the biggest. It's still going to be, oh, that's interesting. Look, you thought it was 15 because of here, but if you take the absolute value of all of the outputs, this one now becomes the maximum speed. The minimum speed is always 0. To remind you what that looks like, all you would do is just put an absolute value sign here and watch what happens when you do that. If I put an absolute value, so look, here's the original, here's the absolute value. What's the smallest thing you see? Only zeros. All right, when is the particle not moving? That's the same thing as the roots, right? So the particle is not moving at the roots. And when does the particle change direction? Same thing at the roots. When you do this one, I'll let you do it. I'm going to talk you through it. Looks something like this. Again, you have to change the range to 0 to 3,650, and the domain is right there. I did show you the initial value, right, is 3,650. It looks like I have a typo in there that I'll fix real quick. So here's the question. What does this mean? Well, number one, it means there's no roots. If there are no roots, it doesn't factor. This means that it's always positive. So it means it's always moving to the right and never moving to the left. But in this problem, it's up or down. So it's always moving. She's always moving up and never moving down the entire problem. Some other things that could come up are what are the relative mins? So the relative mins are here and here. This is the absolute min. What are the relative maximums? There are 3 of them, 1, 2, and 3. And you're going to need to find them in the chart. One thing I would add in the chart, it doesn't say 20, but notice that I added it to mine, so you'd want to include that. Some other things I could ask is what is this maximum speed? You'd want to take the absolute value of all of your maximums and minimums and see which one's the largest. And that'll probably do it. So hopefully that will help you through that one. Well, I hope you have a good experience with this homework. It does have a lot of interesting and good parts to it that'll help you think. And the whole point of this is not to, torture you with math. It's to really get you to understand why math matters so much to people outside of school, and just to get you to think more deeply about what we're trying to learn. Hope you had a good experience with this, and please ask questions in class if you need more help.